Hello everyone, my name is Espik23 here for a KTaNE module tutorial. In this tutorial we're going to be looking at the cruel code module. So this module has a little bit of interesting history. It was first released on March 2018 and was then taken off the workshop in August 2018. For reasons that I have no idea why. However, recently it has been re-added to the workshop and it works just like it did before. However, there is one more rule that has been added in its updates. So we're going to go through this module. This is what it looks like. So in the regular code, we had one 4-digit number which we take to get a result from. In the cruel code, there are three. They are called N1, N2, and N3. So N1 is the first number that you see right here, so it's going to be 3606. To get the next one, we press this red query button. Now we have N2, which is 9932. And we're going to press this query button again to get 1204. If I were to press the query button again, it would actually strike me and I would get 3 new numbers. And the module essentially just resets. So do not press this button a third time. So the rules for determining the code we submit are right here. We're going to start by looking at these formulae right here. So the first function of the formulae is dr of x. This is the digital root of whatever we're putting in. The digital root is the consecutive sum of the number's digits until it becomes one digit. There is a module called digital root, and there's a tutorial for that if you want to find out more of what I'm talking about. Then we have square root. Some of you probably know what this is square root. And here we have this one. This may not be familiar with some of you guys. This is the floor function, flooring z. So essentially what flooring is we're rounding down to the nearest integer. I have a calculator right here, Desmos, which I'll be using for this tutorial. I usually just use my own calculator. I have a TI-84. However, this module is very focused on math, and I kind of want to explain how the functions work. So I'm going to be using Desmos today. I can't use the calculator app since I can't get it to work with OBS right now. So let's start. First rule: if the floor of the square root of n1 is 35. The square root, we're going to find the square root of this, so I'm going to type in square root of 3606. We have 60.05. If we round down, that gives us 60, and 60 is not 35, so next. Otherwise, if the digital root of n1 equals the digital root of n3, so n1 we have 3606 and 1204. So digital root would be 3 plus 6 plus 0 plus 6, and then 1 plus 2 plus 0 plus 4. This will be 12, which would be 15, and the digital root of that is 6. This is 7. So these two are not equal, and we move on. Otherwise, if the floor of the square root of n2 is the floor of the square root of n3, let's look square root of 9932, that is 99, and the square root of 1204 is 34. So they're not equal, so next rule. Otherwise, if cruel piano keys or mastermind cruel is on the bomb, this bomb only consists of cruel code, so no. Otherwise, if the bomb was started on a Monday and a lit bomb indicator is on the bomb, I started this bomb on a Friday, and also this rule is the only edgework rule in the entire manual, so that's the only thing you'll need, and we don't even have that indicator. So next. Otherwise, if exactly 12 solvable modules on the bomb, so 12 modules that aren't needies, the code is 19. We only have 5, so that's not true. Otherwise, the code is the greater value between 1 and the floor of the square. So the floor of the square root of n2 divided by the floor of the square root of n1. Sounds like a little bit. Alright, so first of all, let's get the square root. We already have the square root of this, which is 99. The square root of n1, which is 3606, we have 60. So we take this divided by this, 99 divided by 60, and we get 1.65, and we round that down as well to get 1. So if we were to get something that is less than 2, essentially, we input 1. However, this is the new rule that's been added to the manual. If the answer you get is 0 or 1, the actual answer is this, which is the floor of the square root of n2 plus the floor of the square root of n3 plus n1, modulo 9,999. Modulo is the remainder, essentially, of whatever you're putting in. So we're going to find the floor of the square root of n2, which we already have, plus the square root of n1, or n3, excuse me, which is 1204, which is 99 and 34. So we're going to have 99 plus 34 plus 3606. We have 3739, and we submit 3739. And that is a solved module. Please note that there is no undo button, so that can definitely maybe trip you up sometimes. Alright, here's another one. We have 9174, 8836, and 7349. I'm going to get rid of these. Alright, so let's go through these rules again. If the floor of the square root of n1 is 35, now here's another thing that you can do is, I'm just going to type in 35 squared and 36 squared. So essentially, this first rule is saying, right here, this first rule is saying if the number is between 1225 and 1295. In that case, it's not, so we move on. In case if you don't want to calculate this number every time. Whoops. Otherwise, if the digital root of n1 is n3, so we have 9 plus 1 plus 7 plus 4, and 7 plus 3 plus 4 plus 9. I can already tell right now that these numbers will be different, so no. Otherwise, if square root of 4 square root n2 is 4 square root n3. These numbers, the way that I like to look at this is these numbers are pretty far apart from each other. So usually if they are like within like 100 or maybe even 200 of each other, then calculate it. Otherwise, if they're not, then don't. I don't know the exact calculations for sure. This rule we already know doesn't true, so that one and that one. So these three rules right here will always be the same for all cruel codes. These top three rules will be different depending on every module. Alright, code different between square root of n2 and n1. One thing to note about this is that if n2 is smaller than n1, you will always get 1 for this thing, or 1 for this result, whatever. And then we have to go to this now. So we have the square root of 8836 and the square root of 7349. So we have 94 plus 85 plus 9174. That gives us 9353, and that's what we submit. As you can see, I actually typed it wrong. I pressed 9535. That was my bad. But yeah, if you also might as well explain this right now. If you query more than 3 times, it'll reset, and this will be end 1 right here. So everything resets when you strike on this module. Alright, so here's another bomb with cruel codes. I made it where now, as you can see, if we count, we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 solvable modules in the bomb. The reason is because this rule will now always apply. Whoa, that's not the right highlight. This one right here. So now the code will be 19 if none of these rules apply, and I already know these two won't apply. So we're going to take a look at this one now. So N1 is 4236, N2 is 7604, and N3 is 6085. Alright, if the floor square root of N1 is 35, the code is the result of the digital root of N1 plus N2 plus N3. So the digital root of all that together. And remember, if it turns out to be 1 or 0, you have to follow this again. This rule doesn't apply. Next we have if digital root of n1 equals digital root of n3, the code is the result of the floor of the square root of n3. Alright, let's take a look. 4236 and 6085. That. So 4 plus 2 is 6, 6 plus 3 is 9, and the digital root of 9 plus 6 will be 6, so then we have 6 plus 8 plus 5, which is 14 plus 5, which is 19, which will be 1, and that is also not equal, so I'm going to do that. This one doesn't look like it's going to be true. Otherwise, if floor square root of n2 equals floor sine square 3, the result is the code is the result of the floor of the square root of n1 plus n2. So we add these two numbers together, then get the square root. Not true in this case. So now, since we have 12 solved modules, we enter 19. There we go. That's a solved module. Alright, so there's one more thing I wanted to do before I go, and that is we're going to look at this rule right here. Otherwise, if cruel piano keys are mastered by cruels on the bomb, the code is the total seconds left on the bomb timer when you submit. I just wanted to go over this before we end it. So, let's look at this. We just want to make sure that these top three rules don't apply. So we have 9050, then 8808, and 2900. Let's go through these rules. Square root of n1 is 35. We can just test it right now. Square root of 9050 is 95, so that doesn't apply. Digital root, I can tell you right now that these will not be the same because I'm pretty decent with digital roots. Otherwise, if these two are the same, which they will probably not be, but I'll show you just in case. We have 8808 and square root of 2900. Yeah, they're not equal. Just any SO proof, we will do this anyway. So we have 9 plus 0 plus 5 plus 0, and then 2 plus 9 plus 0 is 0. That'll be 2 plus 9, and then 9 plus 5, which are quite different. Anyway, so now we have this rule right here. We have a mastermind rule right here. So we have the total seconds left on the bomb timer when we submit. So, and remember, there's no undo button. So you will have to pick a time and then submit exactly at that time, no sooner nor later. Otherwise, you'll just get a strike and you'll have to try again. So I'm going to time this for 18 minutes 15, which is, I'm going to time it for 18 minutes, since it might take me a little bit. So 18 minutes, we have 18 times 60 plus 0, or 0 seconds. So we get to 1080, so we're going to be submitting 1080. Now I have to wait for exactly 18 minutes. There we go, and that's a solved module. The code will always change to 1, 2, 3, 4 when it solves. That's just how the module works. So yeah, I'm going to get rid of this since I don't need this anymore. So yeah, this rule right here, just be careful. You basically only get one shot. If you miss it, then you'll have to get a strike and try again. The module's kind of unforgiving in some way, but, you know, I guess it has cruel in the title for a reason. Oh, I didn't know that. Anyway, well, thank you guys for watching this tutorial, and as always, keep talking and don't explode.